Hi, NA Physics, it's Mr. Neff. Let's talk about concave spherical mirrors today. And before we do, did you hear about the doctor who broke his leg while auditioning for the play? I'll tell you about him at the end of the video. The last two videos have been about convex mirrors. And convex mirrors are neat, but they always form the same type of image. Look at this convex mirror simulator that I showed last time from our friends at Pearson Prentice Hall. Here's the object. I can move the object where I want, and you can see what that does to the image. Now, the image always has the same characteristics. Yeah, the image changes in size, it changes in position. DI and HI, they're changing. You can see the rays that we were drawing last time. Here's my parallel ray, here's my focal ray, and here's the chief ray. And you can see that those rays are never going to cross on the left side, and so they have turned them into the back, they've extrapolated them into the back, and they all seem to be coming from this spot. Because it's not real light crossing there, it's where the light seems to be coming from, it's a virtual image. But look at that image. No matter what I do, the image is going to be reduced, the image is going to be upright, and the image is going to be virtual, no matter what I do. Even if I mess around with the mirror, look, I can take the mirror and I can change its curvature, that changes the focal length. Still, virtual, upright, reduced image, no matter what. Now, a concave mirror doesn't act like that. I'm not going to say that it acts differently than a convex. It does act differently than a convex, but a concave will even act differently in different situations. And so that's what I want to focus on here today. So take a look at this example, our first example today. It says we have an object that's placed 11 centimeters in front of a now concave mirror this time, whose focal length is 18 centimeters. Now, one thing right off the bat about a concave mirror, some people would call a concave mirror a positive mirror as opposed to a convex mirror, which they would call it a negative mirror. Positive mirror because the focal point is in front of the mirror. Remember we said that things that are in front of the mirror are positive things and things that are measured behind the mirror are negative things. Also things that are above the principal axis are positive things and things that are below the principal axis are negative things. And so now the focal point, as opposed, remember with the convex mirror, the focal length was back in there and we would call it some negative focal length. Whereas now we have this focal length measured out in front of the mirror, from the vertex, that spot where the principal axis and the mirror intersect, out this way. And so they're telling us that that is 18 centimeters, and I'm going to throw on there that that's a positive 18 centimeters. Now, they're saying that we're putting the object 11 centimeters in front of there. And so I'm going to put this in a spot where I think it looks, you know, there's 9. Let's go just a touch more than that. Okay, and there we have it. Now, the DO, distance to the object, is going to be this right here. And so that DO is going to be a positive 11 centimeters. Those DOs are usually positive, especially whenever you have just one mirror, because it's going to be difficult, if not impossible, to put the object behind the mirror. Okay, and so now they're saying using a ray diagram drawn to scale, measure the location and the height of the image. We're just going to get a pretty good estimate for it. We're going to try to do our very best drawing this ray diagram. So the steps are the same. The first thing I'm going to do is draw the parallel ray, and the parallel ray again is the one that's going to leave parallel to the principal axis. And so here I go, drawing that ray parallel. That's pretty good. And now it hits the mirror and reflects it reflects this time through the focal point. Last time we just had to line up the focal point. This time it actually does go through the focal point. And so I'm lining up my straight edge so that I can go from that spot where it hit the mirror down to the focal point, like so. And there's the parallel ray coming out. Second one is the focal ray. And I'm going to use the same color as I did last time. So this time I'm going to find a line that goes from the candle flame and the focal point, and I'm going to draw along that. And so just like before, the line that's going from the candle flame and the focal point is going to be going along that line. Now, how did I find that? You can't see my ruler here, so I have my ruler lined up just something like that. I'm going to erase those dots now, but I just want you to see that I had my ruler lined up so that I was finding a line formed by the focal point and that candle flame. So I'm going to undo those things right now, those little dots. Okay, now that I've done that, it's going to reflect out parallel to the principal axis. So this is going to go on here something like this. I could have probably done a tiny bit better job drawing that parallel, but we'll say it's okay. Now, sometimes it's not very easy to get the chief ray on one of these. This one looks like it's going to work out pretty well for us. But if there's a picture where you can't get the chief ray, don't get too upset about that. I'm lining up the center in the flame this time. And so right now, my ruler is lined up so that center point and that flame is on the same line, and it's going to go like so and reflect right back along the line from which it came. And so it's going to go right through that center point right there. And there we go. And you can see that blue and black and red are never going to cross over here on the left side, so our imagination is going to extrapolate them back into the mirror. And so I'm going to take my chief and I'm going to extend it back. Now, don't just draw it back with dotted lines. Again, that's the convention for imagination. That's the convention for virtual. I'm going to take the blue one back. Here's this blue one back again, dotted lines because it's not actual light. And the red one's going to come back. And it actually came out pretty nice. That spot right there is where the image of that candle flame is going to be. So this place where they all seem to cross is going to be where that image is. And then the base of the candle is going to be on the principal axis. And so you're going to draw a candle along here, something like this. My candle's sitting on a little dish, so we go like that. And there's the image. Now, how would you describe that image before we go any farther? You could put 3 of those descriptors on. Remember, you're choosing from virtual or real. You're choosing from upright or inverted. And you're choosing from reduced or magnified. Think about that for a sec. Yeah, me too. I'm going to call this virtual. Why? Couple reasons. Number 1, it's dotted lines that are crossing. Number 2, it's behind the mirror. I'm going to call this upright. Why? Because the candle, R-I-G-H-T, because the candle flame is on the top, just like the original candle flame was on the top. It wasn't like it was pointing flame down. And you might be saying, yeah, it's always going to be upright, right? No, it's actually not. Wait for the next example. And then I'm going to say that this is magnified, whereas on the convex mirror, we always saw a little baby image. This time I'm seeing a magnified image. And so those are the 3 descriptors that describe that. Now, this problem wanted us to, well, they wanted us to measure very, very carefully, but they want to measure the location and height of the image. Okay, so if my purple one is 11 centimeters and my red one is 18, then the answer is, how long is this DI? I mean, I'm not sure. It looks like it might be a little bit more than the 11. I'm going to guess it's approximately 12 centimeters. Hey, notice something. It's behind the mirror. And so when we finally get around to doing the calculation on that, that'll be on the mirror equation video. You're going to see that that comes out negative. And then what about the height of this? Well, the height here, height of the image, is going to be this measurement right here. How big would you say that is? That original candle was supposed to be 3 centimeters tall. And I have sort of 2 different scales in the X and Y direction. So don't look at this 18 and the 11 or even the 12 right now. Look at this HO, which they told me was positive 3 centimeters. and say, well, that looks like it's, I don't know, maybe 6. I'm going to call that HI 6 centimeters. It's measured up from the principal axis, so you're going to see the math eventually is going to give us a positive 6. Again, are these the answers? No, when we finally get around to doing the algebra, we probably are going to see slightly different answers, but I'll bet they're in that right ballpark. Now, this was an example where we had the object inside of the focal length. So the focal length, the focal point was right there, and the object was placed right here. And we got this virtual upright magnified image. Now, on my next example, which I'm going to do on the second video for concave mirrors, you're going to see something very different from that. We are also going to get the punchline for that joke. So I'll see you on that other video.